With deploying and managing virtualized workloads involving more than simply taking a workload and virtualizing the servers which it runs on, IT departments can face challenges when it comes to providing on-time services and out-of-box solutions for their application owners. Moving to the virtualized application platform provides greater agility and flexibility, but how do you ensure application consistency and automation and better insight, including monitoring of your application health? The delivery of a virtualized workload is not just about virtualizing the servers themselves, it's about configuring, deploying, and delivering the application workloads that tie into the underlying fabric of your cloud. And these help you gain consistency in the way the application environment is provisioned and deployed, insight into the way the application is running and how it's being monitored, and ultimately control over the deployment process. Now, I'm going to take it for granted that you've got a virtualized infrastructure in place, as per the great whiteboarding video my colleague did. Now, if you've not seen it, make sure you take a look. Now, in that approach, we created the basis of our cloud infrastructure, an agile and flexible virtualized IT, which I can now build services onto. In this case, my service is going to be an application. Now, to me, this is one of the most powerful results of a virtualized infrastructure. The ability to deploy workloads, either Microsoft, third-party, or even custom workloads with repeatability and even automated or self-service solution, responding to the needs of IT. Now first, let's take a look at how VMM helps us create and manage the virtual machines. VMM provides a centralized, granular level of control to IT admins wishing to manage their virtualized infrastructure. Now when creating VMs from scratch, all of the necessary hardware configuration options are presented up front in the wizard, meaning the IT admin can define all the settings now, rather than needing to create the virtual machine retrospectively and modifying the settings later, as with Hyper-V Manager. Now the virtual machine can also be designated as highly available and also at this stage and attached to the relevant networks. Now once VMM has an idea of what the VM will look like from a hardware perspective, it will then analyze the available hosts and then determines which host will be most appropriate to meet the needs of this virtual machine. Okay, well that's great if I want to ad hocly deploy a single machine. Well, we can take that same approach and instead of doing it reactively, let's focus on building a proactive mode, say a blueprint of a virtual machine to support a SQL workload. Now we call this a VM template. Now in Virtual Machine Manager, it's important to think about templates as the final result of combining a series of layers. Now the first of these layers is the hardware layer. Now, this combines various hardware settings such as CPU, memory, networking, and things such as that. And also the creation of a sysprepped VHD file. Now, once an admin has defined a specific type of hardware, it can be saved for a future use, such as a hardware profile. And this hardware profile can be used with other templates or even just with a regular created VM wizard. Now, our next step is the OS configuration. Now VMM allows configuration of domain join, admin password, the product key, and even Windows Server roles and features. And this configuration can also be saved as a guest profile and again used outside of the template process or across multiple templates. And then finally, the application configuration. VMM allows admins to add application level configurations, such as MS Deploy web packages, to accelerate the deployment of pre-configured websites and applications. Server app V packages, which allow admins to create portable virtualized application images for rapid deployment or migration. And finally, SQL DAC packages, which accelerate SQL DB deployment. These application level profiles allow the admin to accelerate the deployment of applications within the virtual machines rather than deploying VMs on their own. In addition, VMM allows admins to add SQL configuration and deployment files to a VM deployment to accelerate DB deployment in the environment. So you can see now we have a blueprint of a virtual machine that we call a VM template. And this VM template is to support a custom workload. And as such, I can publish this for a self-service, asking for a few bits of custom information, such as server name, DB names, even IIS ports, so the deployment can be fast and fluid, with little to no IT action required. Plus, I can use the same template for scale up and scale down. So for example, say I use this to build a web application. I can automate the response via System Center to a CPU overage on the virtual machine, and then System Center will create a new virtual machine and then load balance between the two from this template. And when the capacity need is low, it can then scale back, saving power and resources. Templates provide a consistent, repeatable, and even automated way to deploy your virtual machines. But we just don't stop there. Through a thing we call service templates, System Center offers you the ability to define standardized application blueprints, which can be used to automatically deploy application services to shared resource pools, thus simplifying your application provisioning. Now, defining your application requirements with a repeatable construct like a service template makes provisioning faster and less error-prone than when you manually have to deploy the application. Service templates provide the blueprint for application services, including specifications for the hardware, operating system, and application packages. Same with our VM templates. Now, System Center 2012 supports multiple package types for, say, .NET applications, including the MS Deploy for web tiers. So in this case, this could be my web tier. And then I could actually have a separate application tier, including hardware, operating system, and of course, app settings. And also a SQL DAC for the data tier, which again has hardware, OS, and my app environment. Now, once organizationally approved application blueprints are established and then stored in the Virtual Machine Manager Service Template Library, your application owners are ready to deploy their applications on their own. They can go into the application owner self-service experience in System Center, which we call App Controller, where they can access and select service templates that they've been authorized for. They can easily specify configuration requirements like application topology, scale-out rules, health thresholds, and even upgrade rules into the service template, and then kickstart a one-click deployment. And then before the application owner hits deploy, App Controller provides a compelling visualization of the holistic application service, including all the requested service tiers, the underlying virtual instance templates, storage, compute, and even network resources. This enables application owners to think services, not servers, by offering a server-centric approach to provisioning. And Virtual Machine Manager uses the service template specifications to build out the application tiers, including the various logical instances associated with each tier. In the real world, you're likely to encounter scaled out or multi-instance web front ends, application tiers, and also scaled up and single instance-based database tiers, all running in the same model. Now we have our application deployed, we can use the power of System Center to monitor all the aspects of the workload: hardware, OS, workload support for Microsoft workloads, and also many third-party packages. And even .NET and Java application performance monitoring for your custom applications. System Center Operation Manager enables you to monitor services, devices, and operations for many computers in a single console. Operators can also gain rapid insight into the state of their IT environment, and there are also their IT services running across different systems and workloads by using numerous views that show the state, health, and performance information, as well as alerts generated for availability, performance, configuration, and also security. Now, it's for these reasons that with the Cloud OS, Microsoft is providing the best platform for virtualizing your workloads. With enterprise-class scalability, proven performance, and a plethora of features, it's clear that Hyper-V provides everything you need to virtualize your mission-critical applications. In addition, workload-aware management tools and free add-ons from Microsoft help accelerate the rate of deployment of new services, and then once deployed, help IT monitor, protect, and optimally configure their agile IT. Thank you.